And so that brings me to this week's sandbox. Now, this week's sandbox, or this module's sandbox, I will say this about it. I think this sandbox challenge is more valuable than most of them in terms of getting you working with the material for this week. I highly recommend taking the time to do this sandbox, and I'm going to spend a little bit of time today coding you through this sandbox because I think it's important that you understand what's going on and understand how it works. And so this sandbox, what we're going to be creating is a virtual pet. As a parent of 7 kids, I have no idea why anybody would actually pay money for a toy that gives you more things to do and another thing to take care of. But they've been very popular throughout the last couple of decades, and people seem to like them. And so, and they provide us a really great opportunity here to try out working with classes. And so, if you go into Canvas and you go to the S14 Sandbox Challenge, what you'll see is a pretty detailed description of the class structure of a class called CL Pet. So I've created a Python file that actually already has this class created in it. And if you want to understand the parts of this class, I highly recommend checking out that piece. I'm going to copy and paste this right into my code editor here. Ooh, but not like that. That's terrible. I'm going to download it first and just open it because who wants to indent that many lines of code? I know I don't. So let's put that. Where's my trash file? There it is. Okay, there, that's prettier. So let's walk through this. There's nothing here that we haven't seen already as of today. Okay, so I'm importing the random module, you can see, and then I'm defining the class. Pay attention because when you put together a complex program, you do want to stick to this order. Okay, so you want to first import, then you define classes, then you define functions that are global functions for your program. Then you're going to initialize variables, then you start the code. Okay, that's kind of the order that I'd like you to think about because if you stick to that order, you stick to that pattern, you avoid a lot of headaches. So in this class, we've got an initialization method, and str name is a given via a parameter here. So it's going to take one argument called str name, and then it starts out with something called int hunger and int boredom. So in this game, you're going to create a virtual pet, and that virtual pet is going to progressively get more hungry and more bored. And you have to decide when to feed it, when to play with it. And this game, to make it more difficult, allows you to adopt multiple pets. Okay? And your goal is to not have them leave you because they get hungry or bored. So when you initialize this, you can see it sets these properties, but it also prints out a little feedback. So when you create a new pet, it's going to say you adopt a new pet and name them whatever. The str method, or the string method, you can see here, gives a status update of where the pet is at. It tells you their name, their hunger, and their boredom level. So that's a convenient way to use the string method. We also have a method here that is take turn. So each time we take a turn in the game, this is going to be run for each pet. And you can see the hunger decreases by a random of 0 to 3. The boredom decreases by a random of 0 to 3. And then based on the levels of these things, it will say the pet is hungry. Maybe the pet has found an owner that will feed them. say they're bored, or maybe if they're really bored, if it gets down to 0, then they run away. So those are different outcomes that can happen based on the scores um, of hunger and boredom. There is a feed pet method. So if I feed the pet, the hunger goes up +5, and it says you fed them. You play with the pet, their boredom goes up +5, and so on. Okay, so that is my CL Pet class. That is the blueprint for each pet. Now I have a welcome user function. That's not a method. That doesn't belong to the class. It's a global function, which means it belongs to the program. All it does is print welcome to the pet store. And then the next thing we have is the initialization of some of these things. We initialize the li pets array, or the list where we're going to keep the pet objects. And then we welcome the user, which is just this here. And then it gives the menu options. And then it asks what you'd like to do. This is all very, very familiar to you. Here is the code that you need to fill in. And what I said is I put in comments that allow us to do things. Okay, so I'm still filling this in for you. Okay, so I'm adding. So if we adopt a pet or feed a pet, you can see these are getting filled in. Enter the number of the pet you want to feed. So this is printing for each object of pets. It's printing the name of the pet and the number. And then it's asking which one you want to feed. And then it is saying this. Now, here's where the magic happens. When I want to call the feed pet method on the one that they chose, what I'm doing is I'm asking them to give me the number of what pet they want to feed. I'm subtracting 1 so that it becomes the index, and I'm putting it here. So I'm using it to select a pet in that list by the index, and then I'm calling the feed pet method on that pet, which gives it the +5. So now I need to do the same thing, but for playing with the pet. And so if I want to play with the pet, I'm going to test this really quick, and then I'll go on to the next part. Let's run this. Okay, so here is my welcome. Welcome to the pet store. Here are the options. Let's adopt a pet. Let's adopt a pet whale. You adopted a new pet and named them whale. Let's check on the pets. Okay, if I check on the pets, all it does is go through the list of pets and print their hunger and boredom scores. Let's adopt a new pet. Let's go with dog. I know my names are super creative. So if I check on the pets, whale and dog, I haven't taken any turns yet, but if I feed a pet, I can see how it lists them with the number here. This is just a generated number. I could use the actual index if I wanted to, but I've got it figured out so that it just subtracts 1. So whale is index 0. So if I choose 1 there, it's going to choose whale. I fed the whale. Check on pets. Okay, so now whale has a hunger of 10. So right now, what you might notice is that the pet, we're not taking turn yet. We're not running that anywhere. So we've got to figure out, when do we want to take a turn? Do we take a turn when we adopt a pet? Maybe we do. Maybe that uses up a turn, maybe it doesn't. Obviously, if you adopt a pet and it takes up a turn, that's going to make the game a little more difficult. But I definitely want to take a turn when I feed a pet. And so the way I want to take a turn is using this method for OB pet in LI pets, OB pet, take turn. Okay, so now every time I feed a pet, that's going to use up a turn. And I'm going to take this so I don't have to repeat myself too much. I can even take this and put it in a global function called all turn. So everybody takes a turn, and parentheses, there we go. All turn for each for OB pet and LI pets, take a turn. So let's try this out. All turn, and let's take all turn here. So let's run that and see how that goes. Adopt a pet. Pet's name, Sam. Uh-oh, Sam's already hungry and bored. Let's check on him and see what's going on here. So he's already hungry and bored, and if I feed him, let's feed Sam. He's still bored, but not too bad. So now he's becoming a high maintenance pet, just like a real pet. I know, right? Maybe I should start. One thing I could do to adjust the difficulty here, right, is I could start the pets off with a little bit higher score so that he's not immediately hungry and bored when we leave the store. I don't know if that's realistic because, most of the time they are probably hungry and bored by the time we leave the store. But let's just take this, because we know that hunger and boredom, even though we've given them different names, are basically the same kind of construct. So I should be able to use most of my code here in 3 again for the boredom part. So I'm just going to take all of that and paste it here, and then I'm going to go through and update what needs to be updated. Okay, so let's get rid of this. The int number, again, is used to number off the pets as we go through this. So that's where the 1, 2, 3 in front of them gets generated. Then I want to play with the pet. And I'm going to change this to play pet. We'll still take a turn there. And now I am able to adopt a pet. Let's adopt another pet. George. Uh-oh. Time passes. Sam is hungry. Sam is bored. Let's check on the pets. Okay, so Sam is very hungry and very bored. I'm going to pretend like I don't see that. Maybe I'm a negligent pet owner. And I'm going to feed George. Feed George. And then Sam has run away to find some fun. Now, right now, all I have left is George. Because what happens is down here, the very last part of my loop, the very end, says if the boredom is less than 1 or 0, or if hunger is less than 1 or 0, then I'm going to remove that object from the list. So that's it. If I want to get rid of an object, all I type is li pets remove and the object that I want to remove. And then it's gone, just like that. Really great thing about all of this is that I can save this data using Pickle. So the class, the list that has all of the objects in it, can be saved using Pickle, just like we did with the employee database, and then loaded, and it will be restored back to those objects and with their methods and properties. So this is a really good, pretty far done for you sandbox assignment, but I would highly recommend playing around with it. What I would also recommend that you do is spend a little bit of time customizing this. Maybe add a third thing like emotional well-being or something like that. See if you can add a third property for the pet, or maybe give each pet a collection of toys, a property that lives inside that class that's a list. Maybe you give another property like the breed of dog or the species of the pet. So think of some other things that you can do. Try modifying those objects, and in doing the modifications of those objects, you're going to get a little bit more comfortable using object-oriented programming.